Okay, we're now looking at bearings, and the point about bearings, suppose this is A and this is B, and they want the bearing of A from B. I'm going to put a north there, as it were, and a north there. The bearing of A from B. So I say, put your feet at A, put your feet at B, here, right, and face the direction you're supposed to be facing, which is there. Right, now the angle we require, which I will do in red, now I've discovered the red colour, is this angle around here. That's the angle we actually want. Yeah. That's the bearing, and that's it. If they wanted the bearing of B from A, you just put your feet at A and you do this angle here, okay? And if it had been like this, and that's the point there, and this is say C and this is say D, the bearing of C from D would be this angle here. The bearing of D from C will be this angle here. And what's the point we need to bear in mind when we're doing that angle? Well, if that angle was 70 degrees, what would the bearing be?
70.
You think the bearing would be 70 degrees, do you? What do you think our bearing would be?
From where? There.
From C to the bearing of D from C is what? I'm saying the angle is 70. I'm asking you what the bearing is.
It's going to be
070. It's 3-figure bearings. Captain, submarine on bearing 004. Bing, bing. 3 figures. Right. Right. Next question. Construction. We've done that one.
Calculate perimeters and areas of shape.
Right, or arcs, okay. Right, let's do this in black again. Right. Suppose you wanted the perimeter of that. Suppose this was 7 and this was 7, and say this was 30. 30, we want the perimeter. So I'll call this x. So x is equal to a fraction of the circumference. So the fraction is 30 over 360. That's the fraction, multiplied by the circumference, which is pi d. So this will be a 12th as it happens in this case. Pi, the diameter is 14, so it's times 14. So it's 14 pi over 12. So that will do for the moment. So the perimeter is equal to 7 add 7, add, I'll cancel that down, which is 7 pi over 6. So the answer is 14 plus 7 pi over 6. And we'll leave the answer, you can probably leave the answer like that. Suppose you wanted the area, suppose you had this one here, and you want the area shaded green. Right, so in this case this is more complicated. Suppose this is 7 and this is 7 and this is say 40. Okay, so the area of the triangle, how would we find the area of the triangle?
Half A.
Yes, okay, half AB sine C. So this will be a half. Area of triangle is equal to half AB sine C. So it's going to be 7 times 7, so it's 49 over 2 sine 40. We'll leave that for the second. Right, now I want the area of the sector of the circle. So the area here would be a fraction of the circle. So it's 40 over 360 times pi times 7 squared in this case, won't it be? So it's going to be 49 pi. I can see the 40 will cancel with the 360 to give me 9. Okay, so unless we're asked for the angle, we don't need to work that all out. So the green area or shaded area will equal the big area, which is the sector, which is 49 pi over 9, minus the area of the triangle, which is 49 over 2 sine 40, and do that on a calculator or your toes, as the case may be. Okay, convert between area measure. Okay, what about this one here? 5 centimeters squared. Convert that to millimeters. What would you do?
Times by 100.
It would be
Well, you could write this as 1 centimetre times 5 centimetres. This is one way of thinking about it. And then 1 centimetre is 10 millimetres, and 5 centimetres is 5 millimetres. So the answer here is 50 millimetres, yes. So that was a deliberate mistake to make sure you were still awake. So it's 50 millimetres squared. Okay. Suppose you had to turn 1 metre, cubic metre, into centimetres. What would the answer? Do you know what the answer is?
Would it be?
Well, we could write 1 metre. How much?
100 no.
It would be. It wouldn't be 1,000.
That would be 100 centimetres for that, won't it? And 100 centimetres for that. And 100 centimetres for that.
Oh yeah, so it'll be 9 zeros.
So the answer will be 1 with 6 zeros, which is actually 1 million. So in a cubic metre, there are 1 million cubic centimetres. The other thing I haven't seen on here actually, know about units. If I told you that the area of a shape was A, B, C plus D, E, you would say, well, that can't be the area of a shape, because we've got length times length times length, which is length cubed, which can't be area. Okay. So the formula always has to have the right units. And a common question is this, where they say A, B plus C, D, E squared, etc. Choose the one which represents volume, etc. We've done that one here. Right. Applying data. Oh, don't like that. Forget that.
Pretty easy. Just like histogram and stuff, right?
Right. Well, we've gone a bit fast there, right?
Box plot and everything.
Line of best fit, probability. Do they no one to add? Okay. So the probability. How can I say? Right. The probability of something of winning, let's say, is 5 over 100, shall we say, right? What's the probability of winning 2 games on the trot, as it were, of just one game? What's probably next time? So it'd be 5 over 100 multiplied by 500. It gets less likely, right? Winning once is lucky enough. Winning twice is ultra lucky. Winning 3 times, you start an investigation. And tree diagrams, outcomes. Okay, so a tree diagram is one useful way of doing it. Okay. Right. What else is that? All these words they have on this thing here. Right, I'm going to pause this. Pause.